أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum warahmatullahi wabarakatuh. And good evening and all everyone. We'll start the class, right? So today in this class, in today's paper class, we are going to discuss regarding the friction and the force. So before Pulhal, we may have taken the printout of the worksheet that I have been shared in the group, right? I hope that you may have got the printouts. So for this question number one, I am going to explain all the theory part which is needed for that question, right? So then after discussing all the theory part that is needed for that question, you will be able to do that question. Am I right or wrong? After discussing all the theory part that is needed for the question number one, then after discussing all the theory part that is needed for that question, then you will be able to do this. I will give you 5 minutes time to do that question after the explanation of the theory. Okay, keep that one in your mind and we'll start the class. First one, what do you mean by frictional force? Okay, for this question, we need the idea regarding the frictional force, right? So look at the picture here. So if I move a toy that you may have in your home, right? So when you're pushing that car or when you're pulling that car for a distance, what will happen? It will move for a certain distance, and then after what will happen? It will be stopped. Am I right or wrong? The car will be moving for the certain distance, and after moving for that distance, then after what will happen? It will be stopped because of the frictional force. And look at this picture here, Pulal. In the carom disc, you may have seen it, right? When you are shooting that carom disc, what will happen? The disc will be moving for a certain distance, and at one point, what will happen? Automatically, the disc will be stopped because Pulal, the carom board, this surface will apply a opposing force. They will apply a force and they will stop the disc. That opposing force is called as frictional force. Those who didn't get the idea, just look at this picture, right? Here you can see, okay, not this one. Okay. Look at this picture here. Here we are pulling a box, right? So when I am pulling a box, you may have experienced this one, right? It will be very difficult to start the motion at first. After applying 100 Newton, then only it will be starts to move. Before applying 100 Newton or before starting the motion, it will be a very difficult part to move that table because we have the frictional force. The opposing force will be there. Here, for example, just here there's a person, those are pulling a table, but he want to apply a very big force at first. Then after only he will be able to move that table because we have the opposing force that is called as frictional force. Always the frictional force will oppose the motion. It will block the motion. It will stop the motion. If there's any object moving on a surface, definitely the frictional force will stop that motion. I hope that you may have got the idea what is frictional force, right? In the ceramics, this surface will oppose, will be acting a force against the ceramic. And here, when you are pushing a toy, when you are moving a toy, the surface will block that motion of that box, that toy. That opposing force is called as frictional force that is applied by the surface. So I hope that you may have got the idea. What do you mean by frictional force? That the opposing force. Okay. Here, what are the disadvantages of the frictional forces? There are more number of disadvantages. Look at this picture. Look at this picture. In the engines, Pulal, there will be axles, right? Like this, right? They will be rotating in an order. So when these two surfaces are contact each other, what will happen? Automatically, there will be a frictional force. Right? For example, just take your hand and rub like this. Take your hand and rub like this. So because of the opposing force, when you're moving this hand will oppose the motion of this hand, and this surface will oppose the motion of this hand. So automatically what will happen, when you are rubbing like this, automatically heat will be produced because of the frictional force. So in the engines and all, when the axles are running like this and when the axles are moving like this, what will happen? Two surfaces will be contact each other. So when they are got rubbed, we will have the sound energy will be produced, heat energy will be produced. So the energy loss will be happen. Am I right or wrong? We want to waste more amount of energy unwantedly because of the frictional force. Very best example that is in the engine. So when these axles are moving here, these two surfaces are rubbing each other, right? So because of the frictional force, Because of the frictional force, unwantedly the heat energy and the sound energy will be produced here. Okay, so now you may have it. Now one thing, we want to reduce the frictional force because frictional force is not a good. There are more importance in the frictional force, but here in the engine that is a disadvantage, right? And there are some advantage. I will be discussing that part later. So here, Pulahar, to decrease the frictional force in that engine, they are going to apply the lubricants, the oil. In the engine, we are applying the engine oil, right? You know the reason for that one here. Look after the picture here. So after applying the oil, what will happen? Now the two surfaces will be rubbed each. They'll be contact each other, but they can move smoothly after applying the oil. And look at this picture here. Now you can see here these things, these structures can move easily after applying the oil. So now the frictional force has been reduced by applying the oil. Did you get that idea? Here we have reduced the frictional force because in the engine, frictional force is not a good thing. It is a bad thing. So I have reduced the frictional force by applying the oil. So now another thing, how to reduce the frictional force, that is ball bearings. Here you may have seen this ball bearing in the cyclist puller, and also in the spinner you may have seen that. In the spinner you will be rotating in the hand, right? So in that spinner, you may have seen the ball bearing. Here, look at these balls here. These are the ball bearings, right? So ball bearings are there. So what will happen? This surface and this surface, they will be rotating easily. These two surfaces will be rotating very easily because of the ball bearing. So when you are putting the balls between two surfaces, those two surfaces can run smoothly. So to reduce the frictional force, number one, that is to apply the grease or any kind of oil or lubricants, and second one, applying fixing the ball bearings. Okay, these are the two things that can we do to reduce the frictional force. And earlier I said that the advantages of the frictional force, one of the advantage, that is in the coil ropes. These things will be needed for this question, right? You may have seen the paper, so those who have done the question, you may have got the idea what is the thing that I am explaining here. Those who haven't done the question, it's okay, fine. These things will be needed to do that question, okay? And look at this picture here. We have taken a rope. So in this rope, you may have seen these ropes can be used as a tug of war. In the company during the what happened? Chitra, the New Year. So during those time, you may have seen the kind of competition, right? So at that time, you may use a coil rope. You know, the coil ropes are the surface is very rough, right? So if during the tug of war, what will happen? It will give a very big grip in our hand. So we can easily push or pull the rope easily. Am I right? Or because of that high frictional force. The surface is rough now. Because of the rough surface, we can easily hold. We can easily hold the rope in my hand. And also, during walking and also in the vehicle tires and all. In last class, in last paper class, you may remember that I have explained regarding that the tires, how that tire helping in the increasing the frictional force, right? Okay. There are some advantages and also there are some disadvantages. Okay. Now, the second part regarding the mass and the weight. This is also will be needed for this question, right? Mass and the weight. Okay. For example, just say if the mass of this guy is 50 kilograms, 50 kilograms. So normally, the mass is measured in kilograms or grams or milligrams. It is not the case, but you want to know the mass is measured in kilograms, right? If they are asking the definition for the mass, you want to say like this: amount of substance, amount of substance. And there's no need to worry about the definition. We will be using the kilogram to measure the mass. Okay. For example, just ignore this example. We'll take a box, right? We'll take a box with 5 kilograms, right? So when you're keeping that box in your head, what will happen to us? When you're keeping that 50 kilogram box in your head, what will happen? Definitely that box will apply a force in your head. Am I right or wrong? When you're keeping a box in your head, definitely that box will apply a force in your head. Am I right or wrong? So now I'm going to calculate how much force will be applied in your head. That is the thing that I'm going to discuss now. 50 kilogram box. Okay. You have kept that 50 kilogram box in your head. You know that 50 kilogram of box will apply a force in your head. Now I'm going to calculate how much force will be applied in your head, right? So there is a method to calculate the weight. That is weight. The force that applied on your head is called as weight. Can anyone tell what is the equation for the weight? Anyone? Those who know the answer? How to calculate? In our first past paper collection series, we have explained this equation and the calculations and all. Can anyone tell me the answer? How to calculate the weight? What is the equation?
Mass into acceleration.
Mass into gravitational acceleration. You know, Pula, the mass that is 50 kilograms. Okay, mass was 50 kilograms. Gravitational acceleration on the earth will be 10 ms minus 2. 10 ms minus 2. So answer will be 500 Newton. 500 Newton. So when you are keeping that 5 kilogram box in your head, he will apply the force. You know that one, but you don't know how much force did that box applied on your head. Now you know the equation how to calculate the weight. That is 50 kilogram into 10 ms minus 2. That is 500 Newton. So here in this part we have discussed what is frictional force, how to reduce the frictional force, and what are the disadvantages of the frictional force, and what are the advantages of the frictional force, and what is mass and what is weight. And next part that is needed for this question, here Pula, just say when you are dropping an object from a tallest building, or when a fruit is falling from a plant for a tree, these example will be frequently asked in the exams. Okay, just say right now here I'm going to drop an object from the Eiffel Tower, no, not Eiffel Tower, Sai you know that it has been bended, right? We'll take it as a long building, right? Okay, now I'm going to drop that object, right? But I'm going to explain what is going to be happen here. Okay, when I am dropping the object, initially the velocity will be zero. Initially velocity will be zero. 0 ms minus 1. And after 1 second, the velocity will be 10 ms minus 1. Then after it will be moving continuously, it will be moving, right? So then after 2 seconds, the velocity will be 20 ms minus 1. And then after 3 seconds, the object will have 30 ms minus 1. This theory, this part will be needed for this question and also for the next question, right? So listen here very carefully. I am dropping an object. At first we had the speed 0 ms minus 1. Then later, after 1 second, it turned into 10 ms minus 2. Then after 2 seconds, it turned into 20. Then after 3 seconds, it turned into 30. So each and every second, the velocity will be increased by 10 by 10 by 10. Did you get that idea? Each and every second, the velocity will be increased by 10. You want to keep that one in your mind very clearly. Okay, so I hope that you have got the idea. So with this idea, I also another important. Okay, here another thing that you want to know. Just try to get the idea. There's no need to get the explanation, because if I explain it, it will take more time. Okay, gravitational acceleration will be always 10 ms minus 2. Gravitational acceleration will be always 10 ms minus 2. That's why, that's why, that's why the velocity increased by 10. Look at the picture here. Each and every second, the velocity increases by 10 by 10 by 10, because always the gravitational acceleration will be 10 ms minus 2. Now, with this idea, do this question. Do this question. I will give you only 5 minutes time, because we don't have enough time and I have given more than 2 days to do that question. So only I will give you only 5 minutes time. So please make it quick and do send me the answers through the WhatsApp or in the chat box quick. No take more time, right? What is the advantage of minimizing the frictional force, and what are the method that can be reduced. All the things I have explained, all the things what is needed for this question. And how to find the weight, and how to find the acceleration. I already said that what is acceleration, and how to find the weight, and how to reduce the frictional force, advantage of using the coil rope. All the thing I have explained, so please make it quick. Don't take more time, Pulahanu. Right, within 5 minutes try to find the answer, right? I have explained all the basic idea that is needed for this question. Can you raise your hand those who have taken the printout of the worksheet that I have been shared in the group? Can you raise your hand those who have taken the printout? Four of you have, five of you have taken the printout. Okay, very good. And six. Okay, fine. So please, others will. I already said that to take the printout, right? So without the printout, it will be very difficult to do the question, right? So you will be using another extra paper, and then after 2 or 3 weeks, you will be throw those papers. And also, if you are if you are revising those part, you don't have the idea which for which question I have written this answer. You'll be confused, right? So it is better to take the printout, and within the printout itself we can write the answers. Quick, Kulal, quick, quick, quick. Quick, Kulal, quick. Don't take more time. Everything hard. You have any answers? Okay. Only one of you has sent me the answers. Only 3 minutes more, right? Fine. Very good. Very good. If the your answer is correct. Only 2 minutes, 3 minutes more. Only 3 minutes more. Right, okay, well, it's being 9 o'clock. Sir, is the recording will be uploaded in the yes, my dear. The recording will be uploaded in the YouTube. Don't worry. And Mohammed asked if this was affordable will be in future. Okay, very good. And for example, okay, 414 can okay, very good. It's fine, very good. Energy is okay. We'll discuss, right? Okay. Well, so now I'm going to explain the question. Asharaf, he has sent me the answer, my dear. Very good. Rocket will move slowly. Okay. I will explain, don't worry. I will explain by applying the oil, by using the weight of the mass. And so yes, okay, it's okay, it's okay. There are some small corrections that to be done. It's okay. Okay, don't worry, Sharaf. There are some small mistakes that to be done. I will explain. Don't worry. Yeah. Okay. Now, sir, can you please send me the recording of the fifth lesson, please? Okay, understanding. Yeah. Okay, okay. Fiction of was a general purpose. Right. Okay. Listen. Okay. Now stop writing. Stop doing all the other words. Now I'm going to explain the question. Okay. First question they are asking, what is the advantage of minimizing the frictional force? I earlier said that because of the frictional force, we have the energy loss, unwanted sound are produced, the heat is produced, so we have the energy loss, right? So by minimizing the frictional force, we can reduce the energy loss. Here, look at this picture. I earlier said that in the engine we are applying the oil to reduce the frictional force because we have the energy loss. When you're rubbing your hand, like heat energy is produced. Same like that, when these two axles are rubbing each other, heat energy will be produced. So to minimize that heat energy, to minimize that sound energy, to minimize the energy loss, we are applying the frictional grease and we are reducing the frictional force. Same like that. In this question, there's a pulley, right? Kappi only. There's a pulley. So here we are reducing the frictional force. We are minimizing the frictional because frictional force because to minimize the energy loss. So what is the advantage? The advantage will be we can reduce the energy loss. Reduce the energy loss. Okay, Babulan. This is the answer for the first one. And second one, write two methods. I earlier explained, Bulal. You may remember that one, right? By applying the grease or any kind of lubricants. And second one, by fixing the ball bearing. So we can reduce the friction by using two methods, by applying lubricants, apply lubricant and Pulahal, Pulahal, the main purpose of the paper class is to practice you for the final exam, right? So next week you will have another paper will be uploaded in the group. So next time, Pulahal, keep a stopwatch or keep the timer. Within 15 minutes, you want to do that question. Then only in the exam you will be able to do the question within that time. If not, it will be very difficult task to do the question within that time. Okay, so keep that one in the mind. So before the class, please do the questions and come to the class. Then only what will happen, you will have the doubts. I was writing this answer, why this answer is wrong? So those kind of questions will be there in your mind when you're doing the question and coming to the class. So please follow those things when you're coming to the next class. Okay, fine. So applying lubricants or fixing the ball bearings. Fixing the ball bearings. And third one, explain the difference between the frictional force which applied on empty bucket and bucket of full water. Okay, listen here, Bilal. This question will be explained later. In our next question, there's a thing, right, regarding the frictional force. So at that time, I will explain that one. Okay, for the third one, don't worry. Yeah, Bilal, when you're applying more and more force, the frictional force also will increase. When I'm applying more and more force, the frictional force also will be increased according to the force that we apply. So that part will be discussed a little bit later, don't worry, right? So if you haven't done that question in it, question number 3, don't worry, keep that one, I will explain later, don't worry. Yeah. Second thing, okay, the first question. The mass of the bucket is 4 kilograms. They are asking the weight. You know the equation, right? Weight is equal to mass into gravitational acceleration. Mass, that already we have explained the equation. You may remember the equation, right? Now only we have explained earlier. Now you know 4 kilograms. Gravitational acceleration will be 10 ms minus 2. So answer will be 40 Newton. Saraf, Tammy, did you get the idea, my dear? Why your answer is wrong? You know the equation, right? I earlier said that by using the box or something, 50 kilogram box was there. I'm going to keep that box in my head. So that box will apply 500 Newton equals 50 kilogram. We have multiplied that 50 by 10. Here, this one. You may remember here. This question, do you remember, my dear? Sharaf, 50 kilogram, 500 liter. Look at the equation here. Look at the equation. Weight is equal to mass into gravitational acceleration. Okay, Madam Sharaf. Did you get the idea? How did I find this answer? நீங்க அனுப்பியிருந்தீங்க answer, but it was a small mistake was there, right? Okay. And question number 5. Find the calculate the acceleration. You know, the acceleration will be 10 ms minus. I said that when an object is falling down, the acceleration will be 10 ms minus 2. And question number B. Calculate the force that exerted on the earth. Here, listen here, Bulal. The box has the weight of 40 Newton, right? So when that box is moving with the 40 Newton, the 40 Newton will never change. 40 Newton, 40 Newton, 40 Newton, 40 Newton, 40 Newton, 40 Newton, 40 Newton. Then after, when they are reaching the earth, when they are reaching the surface, then that object will apply same 40 Newton. Look at this picture. Look at this picture. Okay, here there is an object, right? So we are putting that bucket with what is the mass of the bucket? That was 4 kilogram. Okay. So when I'm putting that 4 kilogram bucket from the top of the building, 4 kilograms, okay, that is mass, and you know the weight, that is 40 Newton. So same 40 Newton will be there. 40 Newton, 40 Newton, 40 Newton, 40 Newton. When they are reaching the earth, the same 40 Newton will be applied. Okay, the question is very, very easy, Pulan. But I think you have been complicated the question. Don't make the question complicated. Okay, so the force that also will be 40 Newton. And question number 6. State a method of wasting the energy. Can anyone tell, Pulan? To what energy the energy loss has been created? Sound energy. The cup, this pulley will create a sound, right? Keech and satam. When I'm putting the water like this, or satam there will be a sound, right? Keech and sound. So energy loss. Sorry, sound energy. The sound energy will be released unwantedly. And you know, when two surfaces are rubbing each other, the heat energy also will be created. You can rub your hand like this. Automatically, the heat energy will be produced because of the frictional force. So when they are asking state a method, you can say sound energy has been released, or we can say heat energy. And question number 7. What is the advantage of using a coir rope here? That is coir, right? Coir. Small typing mistake. Coir rope. What is the purpose of using the coir rope? Already I said that, Pulahan. In the coir rope, you know, the surface is rough, right? So we will have a very good grip. We can easily pull that bucket with the water. Am I right or wrong? When I'm using the nylon wire, nylon ropes or something, the surface is smooth, right? So it will be slip easily. But in the coir rope, sorry, the surface is rough. So because of the rough surface, we can easily pull this bucket. Am I right or wrong? Without any hardship, we can easily pull without slipping down because the surface is rough here. The surface is rough here. So because of the rough soft surface, the high frictional force will be there. So a good grip will be there. So easily we can pull the bucket. So here, what is the advantage of using the coir? Because it has rough surface. It has rough surface. So frictional force will be high. So we can easily pull that bucket. And question number 7. You know, this coir rope, they are environmental friendly because why it is environment friendly? When you are putting into the soil or the land, what will happen? Automatically it will be decomposed. But in the nylon wire and or nylon rope, it will be never decomposed, right? This coir rope will be easily decomposed, so there will be no any harmful for the environment. That's a general question, right? Because it is a natural substance, right? The coir rope has been prepared from the coconut husk, right? So it can be decomposed. So you can say this will be easily decomposed. That is a general question. Don't worry about that one, right? Okay. So can you raise a handful of those who have any doubt in this calculation part or in this question? Except this one, right? Except third one. Except third one. Do you have any other doubts in this question? Just check whether you know how to write the answer for the first one, second one, third one. Just cross check once again. If you have any doubt, you can ask. Quick. Don't take more time for the help. Don't take more time. Okay. Anyone? Anyone? Do you have any doubts to ask? Quick. Shara, is there anything to ask, my dear? Except third one, right? Except third one. I don't. What about others, Pulahan? You can ask if you have any doubt without any hesitations, right? No, right? Okay. So we'll move to the next question, right? So this is the question. So to explain this question, now we are going to discuss. So shouldn't we write the method for question number 5? No. Okay, you are asking like this, right? So if you are willing to write the acceleration, if you are willing to find the acceleration, you can write like this. 20 minus 10, because each and every second the velocity will be increasing 10 by 10 now. So you can write like this. This will be the final velocity. 20. Initial velocity 10. It take another 1 second, right? We have put 2 seconds. That means we have only 1 second between that time interval. We have 1 second. So answer will be 10 ms minus 2. But there is no need to show these calculations and all. Directly we can mention 10 ms minus 2. There's no any issue. Sadiya Mahal. Is it clear, my dear? Nazira, Velanchama. And Shakib, fifth one. Shakib, இப்போ Velanchama, the acceleration party தானேமா அது ஒரு எழுதப்படாத ஒரு விதி மாதிரி. That is not a rule, but that's kind of thing. Gravitational acceleration always will be 10. They have clearly mentioned that broken of the string. The rope has been broke down and now the bucket is going to be fell down. So at that time, gravitational acceleration will be 10. Earlier when I explained in this question, I said that 10, the velocity will be increased by 10 by 10 by 10. So the gravitational acceleration will be 10 ms minus. I have put a big circle mark around that. Is it clear, my dear? Yeah, Nazira and Shakib. Ipa okay உங்களுக்கு? Is it clear?
Yes, sir.
Okay. Nazira, is it clear, my dear?
Yes, sir.
Okay, okay. Fine. Now here we are going to discuss Newton's first law, second law, third law, which is needed for this question, right? So, Sam as earlier, I'm going to discuss all the laws, and after discussing all the laws, I will be giving you 5 minutes to do that question. Okay. Newton first law, Kulahal. Don't expect me to explain this law because in our, I think, before 2 weeks we have explained these laws and we have done the past paper questions under the Newton's laws. So now I'm going to explain very quickly. Okay, here Newton first law states that until an unbalanced force is applied, bodies at rest will be rest. That means, for example, just say if there's a box here in the table, until you apply the force, the object will be rest. Unless you apply the force, the object will be rest. After applying the force, the box will be moved. Okay, but until the kudukam katilum, the body at rest will be rest. Okay, and same like that, Pulal. Same like that. For example, just say if a ball is moving towards you, right? Then you are being like this. The ball is moving towards you. Then you didn't apply any force. Then what will happen? Until you apply the force, until you stop the box, until you stop the ball, until you catch the ball will move with the same velocity. Am I right or wrong? For example, last class I explained by using the goal post. You may have seen a picture of the goalkeeper and the football, right? So the ball will be moved with the same velocity until the goalkeeper stop the ball. So here now just combine first one and second one. Until an unbalanced force is applied, the body at rest will be rest. Body in motion, that means the body which are moving, the ball which are moving. For example, the ball is moving here, right? I didn't apply any force. The ball will move with the same velocity. So until an unbalanced force is applied, body at rest will be at rest. Bodies in motion, those who are moving, they will move with the same velocity. And to explain that one, look at this example, right? Here there is a car and a box moving here. And what happened? Suddenly the car stopped. But here the box is moving forward. Why? Did anybody apply the force on that box? Did anyone apply the force on that box? No, right? No one didn't apply the force. Then how did that box move forward? Because Newton said that until an unbalanced force is applied, until you stop that box, until you catch that box, he said that the body is in motion. The object which are moving, the box was moving earlier, right? So now until you apply the force, until you catch that box, the box will be moving with the same velocity. Now forget about the car. Just look out only the box here. Box just forget the car and now only observe the box here. The box is moving. Okay. Until I stop the box, until I apply the box will move. Am I right or wrong? Now just hide. Take your hand and hide the car. Now only look after the box. Ah, box was moving. Okay, now also box is moving. Box is moving earlier. Okay, now also box is moving because Newton said that until an unbalanced force is applied, the body in motion, the body which are moving, they will move with the same velocity. So this scenario and this scenario in the bus, so this can be explained by using Newton's first law. And now we are going to discuss Newton's third law. Then you may ask, so then what happened to Newton's second law? Because I don't need to explain Newton's second law because last class, not last class, I think before 2 or 3 weeks, I explained the Newton's second law. No? So now I'm going to directly move to the Newton's third law. Okay. Each and every action that's a reaction. That means karma is a boomerang. If you are doing a good thing or a bad thing, definitely that good thing or bad thing will be returned back to you. Same as like that, right? Same as like that here. Every action has equal and opposite reaction. Look at this example here, right? When you're swimming, what will happen? You will apply the force on the water. You will apply the force on the water. Okay, you will apply the force on the water. Then what will happen, Pula? The water will push you forward. You are pushing the water back. The water will push you forward. Same like that during the boating and all. Here you will apply the force backside, the backward. The water will push you forward. This is action. And this is the reaction. Okay, did you get that idea? Okay, okay, regarding the Newton's third law. Okay,
Yes.
fine. Now I'm going to explain another thing, right? Here, this thing. You may remember this one, right? I earlier said that each and every time interval, the velocity will be increasing by 10. Earlier it will be 0. After 1 second, the velocity will be 10. Then after 1 second, the velocity will be 2. Then after 1 second, velocity will be 30. Then after 1 second, velocity will be 40. So when it is moving, each and every time interval, the velocity will be increasing by 10. You may remember that one because this thing will be needed for this question also, right? So keep this one in your mind once again. And here, for the momentum. Momentum is equal to Pulahal, mass into velocity. You know the definition of the momentum, right? How much difficult is to stop the motion. I don't have time to explain that one because if I start to explain, it will take more time. Okay. Now I'm going to discuss only the equation. Momentum is equal to mass into velocity. If the mass is 5 kilograms and if the velocity is 3 meter second minus 1, the momentum will be 15 kilogram ms minus 1. This is the momentum. So now you know the unit for the momentum, that is kilogram ms minus 1. And you know the equation for the momentum, that is mass into velocity. Okay, now with that idea, do this question. And another important thing, Pulahal, when I am explaining this question or when I am explaining the theory part, please don't do any other things. Okay, don't start to write the question when I am explaining. Okay, it's my kind request. Okay, and Pulahal, wait a minute. Okay, do this question. I think you can see the screen, right? Okay. Those who have done the work, please send the answer quickly, right? Don't take more time, Pulahal. Please send it quickly, right? And Pulahal, look at this picture. This is also one of the example for the Newton's third law, right? And you may remember that I have used the same picture in that past paper collection class for the force. Okay. Here, the gun will push the bullet. Okay. The bullet will gun the push. sorry. The gun will push the bullet. Bullet will push the gun back. Okay, then gun will push the bullet. bullet will push the gun back. Newton's third law. Yeah, that's why we are keeping that one in the shoulder. When you're keeping that gun in your face will be collapsed. Okay, so this also can be explained by using the Newton's third law, and this will be the action, and this will be the reaction. Okay, now do this question now. Within 3 minutes, I think you can do the question, right? Within 3 minutes, you can send me the answer. Don't take more time. Don't take more time. Quick, quick, quick. Only 3 minutes, eh? If you have any doubts, you can ask me, right? தம்பி ஷராப் சத்தமில்லா மீக்கிறீங்க நான் ஒரு கேள்வி கேட்டேன் உங்கள்ட்ட விளங்கிச்சோ தெரியாத உங்களுக்கு நான் ஒரு செஞ்ச கேள்வி விளங்கிச்சா உங்களுக்கு is it clear at the previous question? Did you find the mistakes that you have done? Don't worry about the mistakes, okay? Your first time you're doing this question, so it's okay, fine. Why what is the purpose of learning here? Because we want to do mistakes, and from that mistake we want to learn, right? So there's no need to worry about the mistake. என்னடா இவரு எல்லாரும் முன்னுக்கு நம்ம பேரை கூப்பிட்டு சிக்கே நம்ம வானத்தை வாங்குறாரு இதெல்லாம் யோசிக்கப்படாது. ஓகே, பி ஹாப்பி, ரைட்? நீங்க யார் எனக்கு தெரியாது, நான் யார் நம்மளுக்கு தெரியாது, நீங்க யாருன்னு மத்தாக்களுக்கு தெரியாது. ஸோ டோன்ட் வரி அபவுட் தட் வித்வுட் எனி என்ன சொல்றது, எனிதிங் யூ கேன் ஆஸ்க் டவுட், ரைட்? எனி டவுட் யூ கேன் ஆஸ்க். சரியா சாரா? ஓகே, மேக் இட் குவிக், டோன்ட் டேக் மோர் டைம். Ta-ta. Okay, very good. Jaza Hilmi has sent me the correct answer for the A and the B. For the what about the third one? The jumping out of the car. I have shown a picture, right? Newton's first law. That will be explained. The third scenario can be explained by using the Newton's first law. Akif, you have sent me the answer. Yeah, Thambi, Akif, you want to mention another important thing that until an unbalanced force is applied, then you want to write something, trace will be stationary, ha 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 ha. You write that one. Before that sentence, you want to mention that until an unbalanced force is applied, that part, okay? Be very careful in that one, okay, my dear? சரி தம்பி ஆக்கிப், எனக்கு உண்மையிலே புதுனமான விஷயம் என்ன தெரியுமா? நீங்க கடும் வேகமா டைப் பண்றீங்களோடாப்பா. Normally, I am very, very slow in typing. I will be typing like this. Then only I can. But you guys, very quick, right? And Shara. இப்பதான் அனுப்பிக்கிறீங்க. Fine. Okay, very good. Very good, very good. Then what about for the B1? They are asking the momentum, right? Zakir, mashallah, he has sent me the answer. Shakib, okay. Oh, என்ன Shakib? அழிச்சிட்டீங்க. Fine. Sharaf, he has sent me the answers. Third law. Sharaf, there's a small mistake in B question. Can you do that one, my dear? For the B1, can you check, please? Okay. So, Bilal, we have only 2 minutes time. So now my time, okay? So now you don't write anything, right? And I didn't study fifth lesson, so hard to study in GP. Okay, Mahal. Friction will be very, very easy. Don't worry. I will explain. Don't worry. Okay. Now it's okay, right, Sharaf. Okay. Now, Bilal. And Shakib, very good. Yes. Okay. Now I'm going to explain. Don't do any other words. Just listen to me. Okay. And here, this is related to the third law. Nothing to explain, right? The gun explained by using the picture, right? And also in the board, he will apply the force, and the water will apply the force on that boat. That is also third law. And that the car jumping out of the car, in this case here, this one is here, this one. This scenario can be explained by using the Newton first law. You may remember that one, right? So now you know Newton first law and the third law, right? So here this scenario can be explained by using Newton first law. So that is okay done. And here they are asking a mango falling freely from a plant took 2 seconds. I earlier said that each and every second the velocity will be increased by 10 by 10. So it has traveled for 2 seconds. That means the velocity will be increasing up to 20. Why? At first it will be 0 ms minus 1. Then after what will happen? After 1 second, the velocity will be increased up to 10 ms minus 1. Then after 2 seconds, what will happen? Then after 2 seconds means 1 second, another 1 second, totally 2 seconds, right? So it will be moved 20 ms minus. The velocity will be 20 ms minus 1. So that's why I explained this picture. You may remember that one. I said that this thing will be needed again for this question. You may remember that one, right? So here the velocity will be 20 ms minus 1. Okay, there is no need to do any calculation. 2 seconds means 2 ms minus, and that's so 20 ms minus 1. Right, okay. Zakir, very good, my dear. Yes. And now for the B1, you know how to calculate the momentum, right? You know how to calculate the momentum. Momentum is equal to, the equation, right? Mass into velocity. I will give you only 1 minute time. Please do the calculations, send it to me, because no one haven't sent me the answers. Please calculate the values, because I have given the equation here. You know the values, you know the mass, you know the velocity 20 ms minus 1. So please calculate the value, my dear. Please quickly. Don't take more time, okay? Within 1 minute, you can send me the answer. Just you want to multiply the mass and the velocity. Please don't take more time. Make it quick. No, any answers yet? Okay, now one of you. Okay, I am Umama. Okay, Umama. Oh, mashallah, fine. You have sent me all the answers, right? But okay, my dear. Okay, I will give if the question. Okay, the question has given 3 marks, right? I will give you only 1 mark. Do you know why, Mama? Do you know the reason for that one? Because the mass has given in grams, right? So we want to convert that grams into kilograms now. Sorry, Mama. The mass has given in kilograms. So we want to convert into kilograms. And Shara. Ah, yes. Oh, my dear. I will give you 2 marks. Do you know why? Totally 3 marks. And Shara, you 2 marks. Do you know the reason? Because the unit. That's wrong. Do you know the momentum? The unit for the momentum. Unit for the momentum, that is kilogram ms minus 1. So change that one, Sarah. And Sarah. Sarah. Okay. Don't worry, my dear. Sarah, pichinilla. Try panikiri, answer panikiri. Other variation, okay? You will get 1 marks out of 3 marks. I will explain what is the reason for that one, okay? Right, okay. Look after the question here, my dear. Look after the question. Now I can erase all the things, right? And you know the velocity 20, you know the mass that is 200. Keep that one in your mind, right? Momentum equal to mass in velocity. Okay. This is the equation. The 1 marks for the equation. And now substitution. Mass, that is 200 grams. But we can't put 200 Palahal. We want to divide by 1000. And velocity, that is, already we have calculated the velocity, that is 20 ms minus 1. And this is kilogram. Now we'll cut all the values. 0, 0, 0, 0, 0, 0. Now answer will be 4 kilogram ms minus 1. So I hope that you may have got the idea, right? So yes, exactly, very good. Yes. So those who have done the mistake, don't worry. Those who have done the mistake, don't worry. It's okay, fine. Here we want to do some mistakes, and from the mistakes we want to learn, right? So there's no need to worry about the mistake. Be happy. So I hope that you may have got the idea. So with this information, we'll conclude the class. Okay. And Sarah, அவங்கள நான் ஏமாத்திட்டேன் அப்படிதானே ஃபிக்ஷன் சொல்லி தரேன்னு சொல்லி கூப்பிட்டீங்கோ கடைசியில ஃபிக்ஷனே எனக்கு சொல்லி தரல அப்படித்தானே சார் டோன்ட் வரி டோன்ட் வரி நான் சொல்லி தருவேன் நான் உண்மையில டார்கெட் பண்ணேன் ஃபிக்ஷன் கேர்லி செய்யறதுக்கு தான் இந்த கேர்லி செய்யறதுக்கு பட் யூ ஹவன் கெட் த ப்ராப்பர் டைம் ரைட் ஸோ டோன்ட் வரி ஓகே next time inshallah I will explain in our next paper class we're going to discuss the friction part deeper and more deep okay then so with that information we'll conclude the class subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilayk and good night have a nice day we'll meet in our next class right bye Sakib